for this problem, I just want to start with saying it helps to read the problem all the way, as I worked it out once, without having noticed that we're a cosine here. Oops. Cosine in the first term and a sine in the second term. We want them to both be sines or both be cosines. And the easiest one to change on this is the cosine to a sine. Building off the property that sine squared x plus cosine squared x equals 1, the Pythagorean identity. If we were to solve for cosine squared, I'll subtract sine squared x from both sides. And I'd have cosine squared x equals 1 minus sine squared x. So that this could be turned into, and let me get rid of that flashing part there. This would be 8 times 1 minus sine squared omega, or w, plus 6 sine w minus 9 equals 0. By the way, we were looking for solutions between 0 and 2 pi, not inclusive of the 2 pi. So now we can work out the algebra a little bit. We have 8 minus 8 sine squared w plus 6 sine w minus 9 equals 0. And these two terms can be combined. That's going to give us negative 8 sine squared w plus 6 sine w minus 1 equals 0. By the way, I realize someone's probably out there banging their head against a computer calling that an omega. It could be a lowercase omega or a w. It really doesn't matter. It is a variable. What I like to do here is to divide everything by negative 1, and I'd end up with 8 sine squared w minus 6 sine w plus 1 equals 0. And if I were to do the u substitution, u equals sine w, I'd have 8u squared minus 6u plus 1 equals 0. So if I'm going to use the AC technique, or you can just do factoring, or use quadratic formula if you want. 8 times 1 is 8. Factors of 8 that add to be negative 6 would be like negative 4 and negative 2. So 8u squared minus 2u, or I guess I did 2u that time. I'll go, it doesn't matter, you can do 2 or 4. I want to go 4 first, minus 4u minus 2u plus 1 equals 0. And I'll have 8u squared minus 4u. So these group together. Then minus, and I'll have my 2u minus 1. And as you saw in the last problem, this negative times a negative is that positive, equals 0. So out of the first pair, I have a 4u times 2u minus 1. Out of the second pair, just a 1 times 2u minus 1. So we have 4u minus 1 equals 0, or no, sorry, jumping ahead of myself there, times 2u minus 1 equals 0. So if I have 4u minus 1 is 0, that means 4u equals 1, or u equals 1/4. If I have 2u minus 1 equals 0, then 2u equals 1, or u equals 1/2. So I'm hoping I'm not getting too close to the next problem. I spaced out. So I have sine w equals 1/4, or sine w equals 1/2. Now, if you're up on your trig values, which I really hope you all are, you know that there are two solutions for the second part. That'd be w equals pi over 6 and 5 pi over 6. For the other part, sine of w is 1/4. That means w equals sine inverse of 1/4, or arcsine. So that means, what are we going to get? I'm getting out my calculator here. I will do my arcsine of 0.25, and I get 0.25268. Now that is talking about an angle here, 0.25268. If you round it to 3 places, it'd be 0.253. But that'd also be the reference angle over here, 0.25268. And so we would subtract from pi to get the rest of it. So pi minus 0.25268 is what? And come back to my calculator here. I have a pi button. Pi minus 0.25268. And I get 2.88891. 2. If you go into 3 places, it's going to be 2.889. So our 4 solutions are pi over 6, 5 pi over 6, 0.253, and 0.2889. That's it.